In this lesson, we'll be talking about strings with Python. We've used the string data type quite a bit already. Strings are different from ints and floats and booleans, which are called primitive data types. Strings are actually made up of characters or single letters. So a string can be considered a compound data type, just like lists are compound data types. In other languages like Java and C++, characters have a data type of their own, but that doesn't exist in Python. String literals, as we've already seen, are enclosed in single quotes, double quotes, or triple quotes. Python also has a built-in class called str. So let's look at what might happen in an interpreter. In an interpreter, we could have the string hello with single quotes, double quotes, triple quotes made up of single quotes, or triple quotes made up of double quotes. And notice that they're all evaluating to the same exact string. If you check the type of the string, you will see that there is a class called str, which is the data type. A double quoted string literal can contain single quotes, like in this example where you have what's up, which has a single quote in it. And a single quoted string can contain double quotes, where we have someone quoting something. For example, she said hello, where hello is enclosed in double quotes. A string literal can also span multiple lines, but you need a backslash at the end of it. We'll see an example in a little bit. And string literals with triple quotes can span multiple lines without needing any extra backslashes. So in the example you will see, we have a variable s1, which is a single quoted string that spans multiple lines, and we're using a backslash where the line breaks. And we have a variable s2, which is a triple quoted string that also spans multiple lines, but we don't need a backslash here. If we were to print these two, the output would look as follows. Note that there is no line break preserved for the first string, but it is preserved for the triple quoted string. We can use the plus overloaded operator to concatenate two strings. So if we had a string hello, and we also had a variable that was holding a number, in this first example here, hello concatenated with there is perfectly fine. But you'll notice shortly, pi is, which is a string, concatenated with a number is not okay. In other languages such as Java, the plus operator automatically will convert numbers into strings so they can be concatenated. That is not the case with Python. You have to explicitly convert it using str. So if you were to run the above, you will still get the hello there, which is the first thing, and then you will get an error where it's saying that you cannot concatenate a string with a float. We can use the bracket operator, just like we did with lists, to index into a string. For example, we have a variable called question, where we're storing what's up, question mark, and then we can extract a character at index 4 and print it. Now, as with lists, indices start with 0, so 4 here is actually the fifth character, so it'll be 0, 1, 2, 3, 4, and that is why you get the character single quote there. We have a len function that gives us the number of characters in the list. So len question gives us 10 because there are 10 characters here. 1, 2, 3, 4, 5, 6, 7, which is the space, 8, 9, and 10. Now calling question and indexing into len question will give you an error because valid indices range from 0 to len question minus 1 because it starts with 0. And you will get an informative error, which is index error, string index out of range, which is fairly helpful. Now, an alternative way to get to the last character is to use a negative indexing. So here you have question -1, which gives you the last character. Question -2, which gives you the second to last character. Note that you can't use the bracket operator to change a list. For example, doing question index 0 and changing it to a capital W will not work. And that might seem strange because you could do that with a list, but this does not work with strings. And that is because once strings are created, they cannot be changed. They are called immutable. Now, note that you might recall that, hey, I was able to do something like this. I had question. I was able to assign it something new here. Now, what's up without the question mark, but with a capital W? What's happening here is this assignment is creating a completely new copy of a string and assigning it question. It's not modifying the original string that you had. Similarly, we can use the overloaded concatenation operator plus to add the question mark. This again is not modifying this string, it's creating a whole new string and assigning it to this variable. Now sometimes we need to iterate over the characters of a string, and you can do this with a while loop. So we have our original variable string called question mark, and we have created a counter. We have our stopping condition. So we want to stop before we get to the end of the list, and then we print the character at that index. We increment the counter, and at the end of the whole while loop we print done. If we were to actually copy this and try to run it just to see how this would work, and actually we do need to pick up our question, so we'll copy that as well, and we'll put that right at the top, and we'll add our question mark. If we were to run this, we would see the characters one by one being printed. We can also do this in the reverse order and print it backwards. So let's copy this, and then I'll talk about the code here. So in this case, our counter starts at the end. We're checking for the beginning. We print it, and we decrement the counter. Now in this case, it's going to print it backwards. And so from the question mark all the way down to the W. So as I said, there are three things you need to do with a loop. You need to initialize your counter, have a good stopping condition, and update the counter. Now luckily, we have the for loop, which makes this job a lot easier. So we can have for. C is our loop variable, and we say in question, which is the string. We just print it. That's all that's needed. So let's try this out and see what that looks like. A much shorter version. It does exactly the same thing for a lot less code. We have the notion of a slice operator, which is in brackets m:(n), where m and n are numbers. This gives us a substring containing characters starting at position or index m, going all the way to n exclusive or n-1. So here for question index 0:4, this will take us from position 0 to 3, which will give us the substring what. Similarly, if we did 7:9, it'll give us the substring up. Note that m defaults to 0, so if you skip it, it'll default to 0, and n will default to the end of the string. So in this first example, we have question :4. So this starts at position 0 and goes to position 3, so you get the what. The second example, if you had question 4:, it's going to start at position 4 and go to the end of the string. Now here's a question. What would happen if I provided neither m nor n? What would that return? Or if I provided 4:4, so it's supposed to start at 4 but end at 3, what would that mean? Actually, the first form will give you the whole string if you provide neither, because starting at 0 and going to the end of the string, so that makes sense. In this case, it's going to give you an empty string. Now, we can also use are normal comparison operators such as equal to, less than, greater than, etc. with strings. So if you took a slice which contained what and compared it, it'll give you a true. And then here you're comparing with up. The difference is that this is a capital U, but this slice gives you up with a lowercase u, so that gives you false. You can also check alphanumeric order using the less than, greater than. The interesting thing here is uppercase letter come before lowercase letters and numbers before letters. So apple with a P here is comes after ape with an E. A capital A comes actually before a lowercase a. And numbers, they come before in ordering than any letter. There are a number of common string functions available to us. So if we had a hypothetical variable s of type string, we could use all of these string functions or methods. S lower will convert the string s to all lowercase. S upper will convert it all to uppercase. S strip will get rid of any white space before or at the end of the string. Is alpha tests if all the characters in string s are alphabets. Is digit tests it for numbers. Is space tests if all the characters represent spaces such as tabs or spaces. Starts with tests if the string s starts with the string represented by s1. Ends with, similarly, tests whether the string s ends with the string represented by s1. Now sfind searches for the string s1 in the string s and actually returns the index where it first finds it. If it doesn't find it, it returns a -1. Replace looks for occurrences of s1 within the string s and replaces all occurrences of s1 with string s2. So these are some methods that might be useful. Our final topic is something called formatted string literals, also known as f-string. They provide a concise way to embed expressions inside string literals to help us format the output better. To create an f-string, you prefix the string with a lowercase or uppercase f right before the opening question mark. Inside the string, then, you can embed expressions enclosed in curly braces. And these expressions are evaluated at runtime, and their values are inserted in those places in the string. So let's take an example. Here we have two variables, name and age. Name is Alice, age is the number 30. And here we are printing an f string. Now you have the lowercase f before the opening quote. And we have two places where we have curly braces and expressions inside them. Right? Here's another example where we have two numbers, and similarly we have expressions. In this case, we are adding two of the numbers. This would output the following, where the values of the expressions have been inserted in the corresponding locations. Now beyond this, f-strings also allow you to control the formatting with something called format specifiers within the curly braces. Now these show up after a colon, and I'll show this in a little bit. And they allow you to control things like how many places after the decimal point, alignment, left justification or right justification. So let's take a look at an example. Here I have a float called price, and it is a longish number, 19.9912. I'm printing the price, and then I'm also printing a literal here, 42. Here is the format specifier here, and here it is for the second example, right? If we were to print this, it would basically print the following. Now I have square braces inserted artificially here to allow you to show the justification a little bit better. So let's take a look at the first one. Here I have colon 8.2f. Now f indicates that this is a floating point number. D indicates that this is an integer. Now the 8 after the colon and the 5 here indicate the column width over which this value will be printed. So in the first case, the column width from here to here is 8 characters. For the second one, it is 5 characters. The 0.2 for the first example indicates there are going to be 2 digits after the decimal point, as they're shown here. So again, looking at each of these specifiers in a little bit more detail, the 8.2f for the floating point number price says that it's going to be printed over 8 spaces. It's going to be right justified, and that there'll be 2 numbers after the decimal point. The specifier less than 5D for the literal 42 indicates that this integer literal will be printed over 5 spaces, and it'll be left justified. If you want to know more about formatting specifier, there's a link I am providing here. So this has been a lesson on strings with Python. Thank you.